Okay, so now we're going to do a review of the graph algorithms chapter for your final exam. So in here, I think there were some questions in your homework. What is the difference between distance vector routing and link state routing? So that is something you can expect in your final exam. You need to know what an autonomous system is in a network. Um, Now, moving forward, you do not need to remember the shortest path algorithm or Shandy and Mistra's algorithm. You don't need to remember these algorithms, the distance vector. You do need to remember what counting to infinity problem is and how that happens, okay, how you end up in a counting to infinity problem. You should be able to describe it in your own words. Now, when it comes to link state, you should be able to describe what a link state packet is. We have covered the definition of the link state routing and distance vector routing when we did the differences between and some main points in both kinds of routing when we did the differences between the two kinds of routing. So if you cover those main points, that should be enough until here. Now, when it comes to interval routing, given a tree, okay, given a tree structure, you should be able to label each of the nodes, and you should also be able to label the ports, right? The outgoing ports and the incoming ports at each of the nodes, right? So this was, I think, a question in your homework. So you can expect a similar kind of a problem in your final exam. Now, similarly, you should also expect a problem-solving kind of a question from your prefix routing, where you're basically given a tree, and let's say you're another node that has to be inserted into the tree, then you should know where exactly the node fits into the tree. So for example, if there was a dot a dot a that has to be inserted into the tree, you have to know it has to be connected to the node which has a dot a, all right, as the label. So you need to know how the prefix routing works, and you need to, they can be a problem-solving questions where you can be asked as to where a new node goes in an existing tree. Now moving forward, in spanning tree, you need to know how the, let's say, the Tarry's algorithm works, right? You need to know how the Tarry's algorithm works. You should know, you should be able to give a possible route taken using the Tarry's algorithm and the resulting tree formed, right, using the Tarry's algorithm when you're given a graph. Okay, so you could be given a graph like the one that is shown in the slide here, and you can be asked for a possible route that you can follow using the Tarry's algorithm, and what is the tree that you end up with after following that route. Okay, so that is a possible question. Now you should be able to define what a minimum spanning tree is, right? You should know the definition of a minimum spanning tree. And finally, the most important problem that you could expect is the Gallagher-Hamlet-Spira algorithm of basically finding a spanning tree. So there was a problem on this in your homework where you had to find the spanning tree when you were given a graph, right? You do not need to remember any of these steps, right? You do not need to remember any of these steps of how the algorithm works. However, you do need to know how to come up with a spanning tree if you are given a graph like the one in this example or the problem that was given to you in your homework. Okay, and that is all from this chapter for your final exam.